The topic is solving first order linear differential equations using integrating factor. So let's do this example. Find the general solution to the differential equation x squared y prime plus x times x plus 2y equal ex. Again, if you look at the definition, we need to put the linear differential equation in standard form. Here's the standard form. So somehow we need to get rid of this x squared. So how do we do that? We divide both sides by x squared. If you do that, you get x squared over x squared, which is y prime, and then x over x squared, which is going to be x plus 2. There's going to be one x left in the denominator, and then this is going to be ex over x squared. Number 2, we need to calculate integrating factor, which is e to the integral of p of x dx. See, p of x is the coefficient of y. So this is my p of x. So integrating factor is integral of px dx. In this case, it's ex over x squared dx. Oops, x over. Sorry, this is wrong. This is p of x. I'm just using f of x. So integrating factor is equal integral of x plus 2 over x dx, which is integral e to the integral x over x. I'm going to do it in 2 mini steps. Plus 2 over x dx, which is integral x over x is 1 plus 2 times 1 over x dx. Now integral of 1 is x plus 2. Integral of 1 over x is ln x. Now let me split this in 2. This is the same thing as ex e to ln x. It's multiplication, not addition, right? Multiplication. It's the same thing as ex e ln of x squared. I'm using properties of logarithm. Move the 2 to the exponent. So I is equal ex. E ln x squared is just x squared. By the way, you don't have to use absolute value, but even if you do, it's not going to make any difference because you're squaring it. So ex times x squared. Alright, number 3 says multiply both sides of the standard form by I. So in our case, we need to do it here. So multiply both by x squared ex. So x squared ex, that's the integrating factor, times y prime, plus x squared ex times x plus 2 over x. And then same thing here, x squared ex times ex over x squared. Now let's cancel some stuff. X ex y prime. Cancel x with x. You'll have x ex x plus 2 left times y. Cancel this x squared. Ex times ex is just e to the 2x. Number 4, left side becomes d over dx, or same thing as iy prime, right? So I is, what is I? This is my I, integrating factor, so x squared ex times y prime is equal e to x, right? This means that x squared, take integral of dx of both sides, right? Now x ex y, integral is e to the 2x is an easy integral, 1 over 2 e to x, plus some constants. Now I'm looking for y, so I have to divide everything by x ex. So y is equal e to x over 2x ex plus c divided by x ex. Right? Now what's next? I can rewrite this as y equal e to x over ex is just ex, so it's ex over 2x plus cx. Again, you can see that this is just a transient term. Why? Because the limit of c over x ex as x goes to infinity is 0. This goes to infinity. Infinity times infinity, limits, of course, is infinity, and number over infinity goes to 0. So therefore, c over x ex is a transient term. So if they ask you, is there a transient term? Yes, this is a transient term, this term of the solution. What else? Also, if you've been asked to find the domain of y over x, in this case, you can see x cannot be 0. See, x cannot be 0. Why? See, when we divide here by x squared, we're kind of like assuming x squared is not equal to 0. Right? You can divide by 0. And usually when that happens, the solution might be discontinuous at that singular point, and you can see solution here. Solution is discontinuous at x equals 0. What else? So if you ask for a large interval where y of x is defined, since x cannot be equal to 0, then domain could be 0 infinity or negative infinity 0, one of them. You just have to pick one. Both of them are large enough. And that's it for this example.